All right, good afternoon, everyone. Thank you for attending today's webinar on RESCheck. And this webinar is, of course, recorded, and the recording is going to be posted to our new recording platform. So I'll put the link in the chat to that so you guys can search and filter and do all these fun things with our new platform. More will be added to that platform as well, but the recording will be posted there. So definitely check it out. If there are any issues with audio, feel free to write me in the chat. My name is Erica DeLello. I'm a senior project manager at RESCheck, and this series is sponsored by the Colorado Energy Office with training materials created by Shamskoda Associates. So Andre and I, well, yes, yeah, Andre, last couple of years, we've been working together to put on trainings just like this one. And so we're coming to the end of this webinar series that I've got shown on the screen. So we've got one more scheduled, but that doesn't mean there's not going to be more. We've got a whole list of different training topics that we've heard from you guys in the post-training surveys that we'll be presenting on this year. So keep an eye out for registration for the new webinar series. We will also be adding an R408 LECC, Low Energy and Carbon Code series. That's such like a 2-session series. That's not going to be happening on Wednesday, so definitely keep an eye out for that as well. But that's targeting about May or so. And then I've been talking about this on-demand platform for a while. We are working on those slides. So if you are a jurisdiction or just someone that wants to know more about the IECC 2024, we're creating a go at your own pace class where you guys can take courses on your own time and still get credit for them. So keep an eye out for that as well. Hopefully, we're going to launch that within the next month or two. All right. Next up is technical assistance. If you are a jurisdiction and you are like, shoot, we're coming up on that June 30th deadline and we really want to adopt some new codes, feel free to reach out to me and I'll put my email in the chat just so you guys have it. But we support a whole bunch of different technical assistance for code adoption. As you can see on the screen here, a bunch of different options, and it doesn't end there. So if you have a specific need, just come talk to me about it. All right, for the resources, we are just banging out a bunch of different resources, especially focused on the low energy and carbon code to help with code compliance and enforcement. So I've got a bunch on the screen right now, but keep an eye out because we're adding more. And Andre is actually going to talk about one of those resources today. So definitely stay tuned. Okay. Last but not least is the Colorado Codes helpline. This helpline is available to anyone working on a project in Colorado and can submit a question on any of the I codes or REACH codes in Colorado. So, for example, if you're a jurisdiction, you have a question about code applicability, enforcement, plan review, you can submit a question. Same for a homeowner, engineer, designer. Submit a ticket and a subject matter expert like Andre or myself or one of our other SMEs will get back to you in just a couple of days' time. So I've got the QR code here, but you can also access it through the Code Adoption Toolkit on CEO's website. All right, I'm going to stop sharing and let you share from here, Andre, but just a couple of housekeeping items. Throughout the webinar, we do want to encourage questions, so please use that Q&A. Andre, I think if it sounds okay with you, if we're good on time and we're moving well, I'll kind of insert some questions just so that you know what exactly where the question is referring to. But if it's questions, I'll start saving them to the end if that works for you.
Yeah, that's perfectly fine. You can interrupt me anytime you find it convenient, comfortable, or prudent to share. Otherwise, we can deal with that at the end. Either way, doesn't hurt my feelings one bit.
Perfect. That sounds great. And then lastly, there will be a survey window that pops up. As I said, that survey window, it not only helps us to improve on these webinars, but it also tees up what you guys want to learn about in the future. So we're scheduling those topics now, and we want to hear from you. So definitely include your input in that post-training survey so we can train on those specific topics. All right, I'm gonna go ahead and stop talking and pass it over to you, Andre.
Well, thank you, Erica. Thank you very much for having me today. See a lot of friendly faces in the participants list in here. So thank you all very much for coming and hanging out. We're going to talk about ResCheck today. So today's webinar, I'll be emceeing it, walking you through some of the contents there. My name is Andre Hayen. I've been a code official in Colorado for about 15 years now, and I've served in a number of different roles. Now I work for Shums Coda Associates, and I get to do a lot of cool stuff when it comes to facilitating some energy projects, working with the Excel program that helps with the helpline, number of other things out there. So you may have run into me once or twice on this topic. So let's get into it. What is ResCheck, right? What's the software that we're talking about today? Well, first things first, it's created by the U.S. Department of Energy, and it's a tool that's designed for residential energy code compliance. If you're wondering, well, is there one for commercial code compliance? There is indeed. It's called ComCheck, and the two are based on the scoping associated with each of the relevant code sections for both residential and commercial construction. So that's where that separation occurs there. And it provides a simplified way of looking at the thermal envelope. When we say simplified, what it's doing is actually some pretty intense but simple calculations for you to compare two buildings. And we're going to get into that with some depth today. The things that you want to know about it. Number one, it is free of charge. There's no free quite like free, right? No price quite like free, I should say, right? So it's a great tool, especially if somebody is trying to do something on a budget, especially supporting residential projects, being able to point somebody in the direction of a compliance software that doesn't cost you anything, but a little bit of time and a little bit of know-how, right? And that's the biggest thing is learning how to use the software effectively. It can be used with IRC, IECC residential compliance. There's also modules in there for ASHRAE compliance. There are modules in there for a number of separate state codes and those sorts of things as well. So you can see those listed, and we'll talk a little bit about more about kind of how it goes around supporting all of that. But it's because the basics that this software is predicated on really are just that. They're basics. They are the simple physical rules of how buildings work and how thermal conductance works. And that's really what it's evaluating. So that's why it's able to do that from a number of different perspectives or different code additions there. It focuses on envelope performance. That is its key goal. And we're going to distinguish that from other parts of performance in the energy code, like mechanical performance and lighting performance. Um, excuse me, that might point you in the direction of other pathways or of other software tools out there that might be able to support that sort of analysis. And it uses a pass-fail on the report, which is super nice. Code officials have been used to that for a very long time, looking at that nice big bar that says, hey, you pass or hey, you fail. So, the history of ResCheck, let's start here. It's been around for quite some time, believe it or not. So, the discussion about getting to a model energy code really starts all the way back as far as the 70s and the gas crisis in the United States, right around the time that we start realizing that energy production and energy conservation might be tools that we need as assets in the design world. And we had some groovy, forward-thinking architects, engineers that started to put together one of the first manuals on that, and that came in the form of ASHRAE Standard 90. Later on, there was a model energy code adapted in the 80s, 90s that became the document that we sort of had today as sort of the prototyping that occurred during the previous organizations that represented what now is the International Code Council, where you get your code books from today for the most part. Original one developed into the 1997 Model Energy Code with MEC check or MEC check, right? So that's kind of the basis of how far back this reaches. It's been around for quite some time. Yeah. How does it work? Well, like I said, it does some analysis for you. And what that analysis is doing is a UA trade-off. So what it's doing is demonstrating a comparative analysis between two houses, one designed to the parameters of a code, another designed basically as proposed. And we're going to compare those two, and that's what the box on the right is telling you about. It's developing this methodology for trade-offs, and using all of the things that are components of the thermal envelope. So this can be insulation, windows, a number of different components here that all come together through an analysis of their U factor, which is basically their thermal conductance, right? We'll look at that a little bit later as we look at the 24 code as well. And the square footage or the area that that represents on the total building. And this represents a comparison between a proposed building and a code baseline building at a mathematical level. So in November of 2002, MechCheck was renamed ResCheck to better align with the residential nature of the tool and sort of separate that ResCheck ComCheck designation that I was talking about earlier. So we get these two tools now that are being produced by our Department of Energy and providing resources for us to demonstrate compliance in both residential and commercial construction. And as we look at it longitudinally since 2002, a number of changes have been made. This used to be a desktop-oriented software that you had to download and you'd use. You'd have to update or replace, depending on which version you were looking at. And now we have a web-based platform that's significantly easier to use. It can integrate more features. And we see that just as the code has evolved over time, so too has this software. So in looking at that with a little bit of longitude here, here's a little of what that summary looks like. ResCheck has been around since the early 90s in the Building Energy Codes program. So this is what they labeled it as when they were starting to put this together and really get this moving. By 1998, we're seeing, that, hey, this is being more widely used, and we're starting to develop this UA trade-off based message. In 2000, we get the change from the MEC to the IECC, and we start working off of that as our base code, as our base energy code, especially on the residential side, right? By 2002, we're renaming the software, and then we are, just like we're evolving the code between 2003 and 2012, we are really developing more and more robust toolkit to be able to support the use of this software. 2015 to 2018, we're introducing more state-specific compliance methods as states start to look at multiple ways to achieve sort of advanced energy goals, right? And start taking different tacks or different methods of being able to achieve that. It starts to become much more of a policy driver. By the 2000s, 2020s, excuse me, we get the launch of the ResCheck web cloud-based method. And here we are today, in the modern era where we're using this tool on a regular basis. It's about as close to a household name on a residential project as you can get when it comes to energy use, right? It really has filled that space in a shocking amount of time, only about 30 years. It took it to become what it is today, which is a very commonly used tool. So, what all does it support, right? Well, it's doing this analysis based on the adopted energy code and the climate zone for a jurisdiction. And so that's typically going to include the IECC, some provisions of the IRC if you do it that way, right? There's a number of places that just use the IECC. Some of them do refer you to Chapter 11 out of the IRC, and that might be their energy code, especially for a community that's really focused on that residential side. And then maybe they incorporate like ASHRAE 90.1 separately or something like that for their commercial buildings. So there's more than one way to go about this, right? And then many state-specific amendments have, like I said, filtered its way into what ResCheck does to broaden the scope of its ability to support a number of different codes and a number of different uses in the residential market. And so it's applying those prescriptive baseline values from the selected code edition and climate zone against a proposed value. So it was designed with multiple compliance paths in order to afford flexibility. So what do we mean by that? Well, we know that compliance paths, right, exist in the energy code, and I've got a nice little breakdown of that a little bit further on in the presentation. But typically, we refer to this as part of the component performance alternative method. We've had that for a long time. Sometimes it's referred to as something like a UA trade-off method. This basically is just saying the same thing that, hey, we're going to compare a baseline building with provisions of the code. If we were going to say, hey, I want to change this a little bit, I don't want to do as much insulation in the ceiling. I want to do less insulation in the walls, so I'm going to make up for it in some other place, but I'm going to do that in a way that is limited to the thermal envelope. And generally speaking, that's an acceptable method to be used in a number of different means through multiple different codes. Sometimes there's more expansion of that, and we get into things like ERI and simulated building performance, where now we're looking at the total energy use of the building, not just the performance of the thermal envelope in and of itself. So when we get to the 24 edition, though, we see this idea of TC or thermal conductance beyond simple U factor analysis, which is being presented for the 24 codes. So we take a look at that, right? What does that mean exactly? What is UA versus TC? Well, UA has been the term that we've been using for the overall evaluation of U factor. And now we've moved to a place where the 24 code is replacing that with a term known as thermal conductance, which is meant to capture a more complex definition and include more places that have been sort of the problem places where we've had more leakage and more conduction of heat out of a building than we were basically intending to. This also includes the ability to look at things like slab loss. Now, this is one that's come up quite a bit because for those that have been tracking this conversation for a good long time, the IECC for the longest time really did treat slab edge insulation as a requirement. However, there were some versions of RESCheck that actually allowed it to be traded off, even though it was not necessarily meant to be so, and it caused some confusion out there in the market in a few places. So, in order to accommodate that and some changes to how we do our calculations, broaden the way that we're able to do that, where we have F factor, we have a number of different things in the 24 code that help us broaden that definition. TC is now meant to provide a new comprehensive version of this old concept, which is can we compare the thermal envelopes of two buildings, like for like, and say one is going to perform as adequately as the other, right? So, one of the other things that we want to make mention of here is that the IECC scoping provisions do hold for this. So remember, we're talking about low-rise residential buildings, multifamily buildings, up to 3 stories for its application. Really want to detangle that from that ComCheck narrative, especially for our designers out there that might not be used to designing on the energy code side, right? Remember that the scoping of your commercial building design, which can include things like R2s, and you'd usually build that out of the Blue Book, right? You'd build that out of the IBC. You might still be able to provide the residential application of the provisions of the code for those particular units if it's under that 3 stories. So it's an important one to keep in mind is that those scoping lines don't always line up. We want to make sure that we're paying attention to those as we figure out how we can apply things like a software or the code in the correct method. Right. And it's going to verify the compliance through the envelope trade-offs. So it's going to look at the walls, the ceilings, the floors, the doors, and we're going to see that each of those is independently itemized in the report of a manual, or excuse me, of a res check. So we can look over that with our set of plans and make sure, okay, they planned for this wall to be 2x6 construction with, say, an R19 cavity and maybe an R5 insulation on the exterior. And that is the same thing that they show on this other report, like a res check, right? So we're going to be able to see that compliance documented in multiple places when we use this particular method. And at the end of the day, we're providing this prescriptive alternative approach to things like HERS or ERI ratings or building performance. So basically saying, hey, if you don't want to get all the way into modeling and you don't want to go through the expense and cost of total energy modeling, this still allows you a more simplified approach or a more simplified method to take that on using a free software to do it. So, I've talked a little bit about the fact that there are different pathways in the code. Oftentimes we hear something referred to as the prescriptive method. I'm going to go with the prescriptive method. And I can't blame people for using that term. Prescriptive method was in the code for a good long time. In fact, that was one of the ways that we sort of organized the code. So if we look back on older versions like the 12 and the 15, we saw pathways as advertised as being prescriptive method or as performance-based method, right? And some things were marked as mandatory in those code books. And we've really changed the way that we present that information, getting to more modern versions of the IECC, where now we see a pathway that's sort of designated based on which method you want to use. And those have some elements of, dare I say, certain trade-offs, certain allowances. And you notice what I've highlighted here for you is sort of when they can be traded off. So I'm just going to kind of break down each one in turn. There is the U factor method and fenestration criteria. Now, this is the long division method of figuring out how energy efficient your building is going to be. And when I say long division method, I really kind of mean that it's sort of the most rote, most methodical. It's also highly accurate. But what it's doing is you are looking at every single component. That's why I say component by component method for determining assembly U factor. You're going to look at every piece in a wall system or in a roof system, right? And figure out what it provides in terms of U factor. Then you're going to take that analysis and you're going to figure out exactly what the overall performance of that total square footage of that area is for that building. Now, that should sound oddly familiar to you because I've been describing that a little bit with this. So, if you're unfamiliar with this process and wondering, okay, so RESCheck's doing this U factor analysis, or more modernly, a TC or thermal conductance analysis, if this is what it's providing, how does that work, and why do we have a method that follows it? Well, the method in and of itself is probably the oldest method for figuring out how much heat loss a building is going under. And what it's really doing is figuring out each component in that building and figuring out what the actual performance of it is. And when we look at a component performance alternative, a RESCheck method, more or less, what we're doing is we're doing two of those. We're doing a baseline one based out of the code, and then we're doing one based on what you think you can do as a proposed design. So those are your two kind of relationships there. Then you have one that's probably the most commonly used, the R value alternative. This is the simple, hey, in the code book, tell me what I have to put in the walls and in the ceiling in order to comply, right? I'm going to build this building in a way that's very, very typical, right? I'm going to use 16 on center framing. I'm going to use 2 foot on center trusses. I'm going to blow in my insulation, ventilate my attic. It's just, I am making a very simple box. Just tell me what I have to put in it in order to be compliant. And that's exactly what the R value alternative does. It works on a series of basic assumptions on the way that you're going to frame this building or build this building. It's not performing a U factor method analysis component by component. It's saying, hey, typically, if we insulate this and build this properly, it performs this way. So if you build it to this method, we know that it will perform adequately. That's basically what you're getting out of that. And you notice that the top two there, even though they are part of that prescriptive method, they don't allow a trade-off with it. However, our component performance alternative does. It is by definition trying to allow a trade-off using that twin building concept. So that's that sort of comparison between these three and sort of the important thing that you need to know. So for all my plans examiners out there, one of my biggest suggestions is whenever you get a plan coming in and they say prescriptive method, the important thing is to ask which one, right? There are three valid subcategories in the IECC of which method you're allowed to use. And depending on which one they selected, it will limit some of the things that you're allowed to do. There are certain allowable changes in the code, not trade-offs, but instances where you can reduce the amount of insulation, say in ceilings, for instance, in R202, or excuse me, R402.2.1 for ceilings. You can take a look at that section and see, oh yeah, this allows me some flexibility and I can reduce the amount of insulation I need to put in my roof system. It's a totally valid approach. However, that is also based on the method that they chose. So, for instance, if they give you a RESCheck and they're taking the component performance alternative, they also eliminate some of those options as well. So, recent codes, the 21 and the 24, have asked for a compliance pathway to be part of our construction documents. And this is where I think it's important when we talk about things like RESCheck that they are tools that are complementary with certain pathways and certain uses, which are fantastic. The important thing is to know exactly which one we're working with. So when you can get designers who are putting, hey, I'm going the prescriptive method, R value method, or R value alternative, right? Great. Then I know I'm not looking for an additional report. I'm not looking for a RESCheck from you, and I'm expecting or reviewing directly to what is in the book, right? If there's any variance in those things, then I know that I have something that might be a problem we need to address. Whereas if it just says prescriptive, I don't know if I should be anticipating a RESCheck until I start diving into your plans. So, one of those things to just keep in mind that, whatever compliance method we pick is going to directly correlate to what items we're going to ask for as we move along in the process. So, how does this process work with ResCheck? Well, there are a number of user inputs. There are project details. You have to select what code edition you're going to use. You have to tell us about your building components. And remember, there are a lot of those. Thankfully, though, they take the time to prefabricate a lot of different typical framing methods, typical building methods, so that way we can focus on sort of the realities of what's out there rather than having to make everything from scratch and explain what the U factor is for each of these. It does a really good job of helping you find some of those things. And then fenestration, skylight, and door details as well. So basically everything in the thermal envelope. And then the tool automatically is going to calculate that difference between total UA proposed versus total UA maximum to determine compliance in a pass-fail method. So it's a UA trade-off based approach. Each building has a U factor or effectively a rate of heat loss, and each assembly also has to have an area. So we'll notice that when we look at assemblies, we will see each time how much of the square footage is this particular assembly going to take up, right? How much of this is being calculated into this building. Some of the places where, we see things kind of go wrong on that, you have a residential building with parapet. That parapet wall might be part of the wall assembly and easily mistaken to be calculated into the thermal envelope, even though the height of that wall, maybe for 2, 3, 4 feet, doesn't actually contribute to anything within the thermal envelope, right? That's all stopped at the ceiling level. So there are places where we want to make sure that those are aligned and that we're paying close attention to. But the software calculates a heat loss value for the minimum proposed, the code minimum design and then the proposed design and compares those two. So if I am beating a dead horse, there is good reason for it. I want to be perfectly clear about exactly what this allows. I've got a couple of slides a little further on that goes into what ResCheck is not, but I always think it's important to break that down. So, what goes into this analysis overall when we talk about each of those things? Well, we're going to talk here and make sure that it has its climate zone. You have to have the conditioned floor area, right? We need to know how much of a building we're talking about and how much we're going to be heating, how much is included in this space. We need the number of stories, right? We need to know how tall this thing is. We need to know if it breaks the threshold over 3 stories, and then we can't apply this anymore. We need to know things like the foundation type. We need to know whether or not we're going to have slab edge insulation running down a footing and stem wall. Are we going to be going under a structural slab? Are we going to use a different type, a post-tension slab, for instance, things like that. We have to know a little bit about these details in order to be able to understand how ResCheck's going to apply. We need to know about our building components, our walls, our roofs, our floors, especially over unconditioned space where we're going to be insulating those, right? That's where the big differences matter. Slabs, crawl spaces, windows, skylights, and doors, everything that makes up the thermal envelope. So like I said, there are a lot of questions that I get about ResCheck, especially for first-time users. Folks that are saying, hey, I am trying to understand this. I got modeling as part of ResCheck. Well, no, right? ResCheck does not provide or require full energy modeling, only enough detail to evaluate the envelope performance. It's not looking at mechanical sizing. It's not looking to verify HVAC sizing or efficiency. Doesn't capture air leakage testing, right? That's a common one to potentially trade off on when you look at some really advanced building methods like passive house, things like that, that really get into limiting the amount of air leakage for a building. Doesn't look at lighting controls, right? Doesn't look at any of that good stuff. And this is probably my most important one, the last one. I wanted to end on a high note here. It's not a substitute for the plans that you need. You want alignment between those two plans because I hate to say it, the guy building the building or the gal building the building out there typically is not looking for the res check when they are, cutting rafters or sizing up how their roof is going to frame up, right? They're looking at building plans. And ultimately, you need these on both places, right? You need the assemblies to be pictured in the plan so you know that they're built correctly and then simultaneously conveyed on the res check itself so you know that they were analyzed for their energy performance correctly. So you want to see alignment between those two things. One is not a substitute for the other by any means. So what does it look like? Well, it looks a little something like this, right? So this is one draft project that I pulled. And we can see that we see a few things here right off the get-go. And I hope that you can see that clearly on your screen, but I will try and highlight a little bit of that with my nifty laser pointer here. So we see the location. Oftentimes, this is just a straight up address correlating to the plans. Sometimes, when you're doing production building, this is lot and block numbers, which can be tricky. I know building departments that don't look at lot and block numbers. They look at that and say, absolutely not. And then I know some that are like, yeah, absolutely. We'll go, look that up out of the plat, and that's perfectly fine. But building consistency here, or maybe raising this if somebody is doing a series of res checks for residential builds in your jurisdiction and you're looking at that pre-con opportunity to talk about expectations. If you want these labeled as an address specific means, that's a great opportunity to have that discussion. You notice the construction type is single family. We're talking about a new building here, and we're talking about our orientation that the building faces 270 degrees from north. That means it's going to face west. That is a really important one for us for a couple of reasons, right? We know that heat loss can vary substantially based on whether you face north or south. That can be replicated in both RESCheck and also in manual JD&S, right? Both of those are really important for knowing exactly which direction the building is facing. When we talk about production builds or when we talk about getting involved in a project that's going to have a lot of these coming in, from a plan review standpoint, that's again one of those things you want aligned because if they're turning in effectively the same master home and they're running a res check on that building, but they're putting it on both sides of a street. That's the kind of thing that should be a good trigger point of, oh, we need to see this analysis from both sides. We need to know exactly what's happening here for the building that we're actually reviewing, right? We have a conditioned floor area here. I said 3,000 square feet just for easy math. We have a climate zone of 5B. We have a permit date here, just some other basic information. And again, a good opportunity to see those things aligned from an administrative perspective, but probably not the most important things for folks just learning how to use the software. Now, I promised you guys that you'd have a look at some assemblies, right? And you do, right? Envelope assemblies, like listed here, we can see that we have an area that's all under a cathedral ceiling. We have the gross area at 3,200 square feet. We have a cavity insulation of 38 and then a continuous R value. That's going to be a 5 there. Again, this is one of those things to align with the plans themselves to make sure that, okay, what I've had planned as the roof, because if I look at the roof plan and it shows me, hey, I'm not going to vent the roof and I'm going to spray foam the whole thing, that's going to look really different, right? In terms of performance, air sealing, number of different qualities to it, but also a misalignment between plans and our res check. So, important one to keep in mind, right? We see an area of crawl space here. At the very end, what I want to say is that we have our U factors here of proposed and required, and then TC as well, thermal conductance, and we're also getting a rating for that information there. So all of your assemblies will be categorized in some form like this. And as we look at more and more complex buildings, especially complex residential buildings, we can have dissimilar materials, we can have varying roof sizes and roof depths. We can have walkout basement, so we have an area that extends and adds additional square footage that is above grade wall versus below grade wall. These are all the kind of places that you want to take a look at with your building plans and make sure that there is clear alignment between the envelope assemblies proposed and then what is going to be delivered out in the field when the building is built. Another cool feature is that it helps you tally up energy credits. That's an important thing here, especially looking at the 24 code, having an ability to say, okay, there are a number of items here that this building is going to check off the list for its crediting. In my case here, right, I said it'll be using an option 3 high performance gas furnace and cooling with a gas-fired water heater. That's also going to be high performance there. We're going to do some energy efficient appliances, and in 5B, I still get a little credit for that. Demand responsive thermostat, right? This is another great one here. Easy enough to install. And then 100% of the ducts are going to be in the conditioned space. Well more than enough credits, right? So we see the 10 required for a home built like this, whereas the proposed crediting system would give me 21 credits for all of the things that we said on this res check that we'd be able to do. This is, in my mind, a huge boon to be able to provide a report like this. and a strategy for review on this topic, right? Because energy credits are intimidating. I think Erica made mention that there will be a two-part class out in the future there for the MLECC R408 crediting structure. And I get it. I get why. The movement to a more robust crediting system is definitely a little bit daunting. So a tool like this can really be helpful in understanding what's supposed to be on the plans. And again, going aligning those things with the plans. Based on my proposal here, for my gas fireplace, or excuse me, my gas fireplace, my gas furnace, and my water heating systems, I should be able to go and see those represented on my mechanical or plumbing plans, right, for my appliance schedules. That would make a whole lot of sense that we could see that alignment, make sure that what's been put on the plans is going to make it out there into the field. 100% of the ducts in the conditioned space should tell me a few things. When I see that, I should obviously see a thermal envelope that encapsulates all of that. Maybe they do something like, not ventilate the attic space, right? So we're going to put all that stuff in the attic. That's going to help keep everything inside of there. Maybe they have a second furnace in the basement, right? We're going to see instances where we have all that ducting not passing through areas that are adjacent to exterior walls, taking on some of that potential thermal loss because of that, right? We're going to keep all that on the inside. It also means then that in our manual J, we wouldn't see any loads for those ducts either. So we can see this alignment that can occur through a positive analysis of this topic. Oh, let's see here. There we go. Sorry, I had something pop up on my screen and I couldn't get back to the presentation, but looks like I found it again. So one of the other
Hey, Andre, question for you. Do you see res checks used for additions to existing homes?
sometimes, not super often. I'd say that there's, at least with a lot of the builders I've worked with in the past, what they like to do is just do the R value method for an addition because they know they kind of can't fail with it to a degree. They're not trying to get too creative with that. I have ran into it a few times where folks have wanted to use a res check for an addition, but probably not the most typical method that I've seen, Astrid. But great question. So, yeah, especially on residential. Commercial, I see a lot more com checks for, and not really so much additions, but changes of use or things like that that might be treated like an addition in the code in some ways. So yeah, great question. You got me thinking about that.
Thanks, Andre.
Yeah. So, how do we use it, right? Well, we go and align those things in real life. So, these two plan sets I actually pulled from the Department of Energy itself, from their Building Solutions program. They've got a number of prefabbed different wall cut details that you can use based on climate zone. And so, I just pulled a couple of them out as representative plan samples. But for folks that are trying to explore this or maybe trying to tool around with ResCheck, I would strongly recommend pulling a few of those down, downloading them, and then you can rebuild them in ResCheck and see how close you are, right? Just as like a fun little thought experiment, you can have a few different styles of building, maybe some that you don't typically see. But here we see a ventilated attic, here we see a non-ventilated attic, right? We see different ways of insulating this. One is all on the inside, right? All in the attic space, and another one here, which has some continuous insulation above the roof deck. There's lots of different methods out there, and it's nice to have some tried and true options from DOE that were produced this way because I think the plan cut is really clear. It's really useful, especially as somebody who doesn't look at those. And I think, to Astrid's point on this, some of the biggest issues we have with energy compliance, I would say, is a lot of existing buildings, a lot of folks not knowing how to draw energy, how to work with energy, especially those homeowners that are just focused on, hey, I just want to extend my dining room. That's the whole reason I'm here, and so being able to show them a list of options that's like, hey, any of these are compliant, you can do something else as well. And that's exactly where ResCheck comes in, right? Is let's say that they want to get a little bit more creative about that. I'd say one of the nice things that we have here, once again, is that nice, big, bright bar in the middle of the page that says, hey, pass or fail. And it's going to walk you through exactly why you did. So, in both of these, they're probably a little too small to be able to see easily. These were a couple of old ones that I pulled. And one of the nice things is it's telling you your compliance above code. right? So it's telling you what your UA is. This is on an older version of the IECC. It's on the 15. But it's telling you, hey, this was the UA that you produced for this building, and then using that same building, but maybe with some other issues, like in this case, had invalid solar heat gain coefficients for the windows. It's helping pick some of that information up and ensuring that it makes it out there. But again, just not a substitute for a total plan package. You need the whole thing in order to be able to say that you have it. So here is a visual that I hope you find helpful. This is another way of thinking or looking about residential compliance pathways in the code, right? In the 24 code. You notice that I've been talking about three, but there are four here. Well, unfortunately, it is just wishful thinking that we have a tropical climate region in Colorado. I wish we did, but we don't. So we're stuck with the other three, unfortunately. And so the green ones we already talked about a little bit. That's the prescriptive compliance option. Then we move on to the simulated building performance option. That's going to be a lot more modeling intensive. And then ERI or energy rating index, which you see also has two subcategories, whether or not you're producing on-site power. And so, the bread and butter for the use of this is the component performance alternative, right? That is really the biggest reason why it exists. You will find things like a simulated building performance option on the RESCheck software. And unfortunately, software can't provide the full depth of a simulated building performance, but it can provide parts of it, like the envelope analysis, right? You just have to combine that with other information. So I want to be very clear about kind of the limits of the software, what it can do, and what it can't. So, the prescriptive method, getting back to, part of this question, it's been around for a really long time and people know it well. And sometimes with energy, especially folks that don't work on this on a regular basis and are not trying to leverage all of the flexibility being written into the code, it can be information overload, right? They just want to hear a straight up, hey, tell me what to do. Just tell me, like, I can only frame this with a 2 by 8. I want to know the same thing for energy. I can only put an R30 in this, then I can move on, right? There is a level of that I think exists out there that are just realities and working with people trying to do projects. And so with that, prescriptive method has been sort of tried and true and used for a very long time. It's why people really like it. And that's exactly why tools like ResCheck sought out to support specifically aspects of the prescriptive method. I've known some jurisdictions that just required a ResCheck for every project because it's free software, regardless of whether or not they were taking the component performance alternative. Part of it was to itemize all of the insulation and energy compliance information that they wanted to get on the project. And I can understand the rationale behind it, but the versatility of the tool really does come from its use with the compliance path that's appropriate. It's great for additions, great for remodels, right? Like I said with Astrid, it absolutely does work for that. I just run into a lot of people that tend to want to use the prescriptive method, especially getting started. But like the last jurisdiction I worked for out in Jefferson County, I would say, majority of our projects were really focused on, it's a little bit more bedroom community-ish. And just a lot more projects were based on like simple residential projects for folks. That's what I often saw coming in, unless somebody was, doing the full track home build or things like that. So that's just my 2 cents on that, though. And once again, it's important to remember that this does not support all the mechanical information that you need. So manual JD&S, air leakage testing, air barrier installation information, all of those things really do need to come with all the documentation you need to say that you have a compliant building. The res check alone won't get you there, but it's a good part. Good point. Remember in R408.2, that's where we get our credits requirements, right? And the applicability to that is for our projects that have prescriptive method. So that includes things like our component performance alternative. Other types of projects, if you go ERI or you go simulated building performance, typically going to show their compliance with that additional sort of measure through even more reduced energy use, right? And we see that captured in the code. But I do want to parse that out, that one of those tools being the additional efficiency requirements sort of list or report out of it. Super useful, but applicable only to certain code paths as well. So ResCheck's especially useful for those simple projects, single families, townhomes, and providing consistent and standardized compliance document that people learn how to read quickly, get effective with. It helps reduce errors from calculations, creates a clear compliance record, and helps reviewers quickly confirm envelope performance. So, what does ResCheck mean for my process? And I think this is where a lot of our viewers or a lot of the folks that attend these want to know from a brass tacks perspective, how do I use ResCheck when I'm doing a plan review or doing an inspection, right? So first things first, right? If we're going to integrate this, we'll start on the left with plan review. We're going to make sure that it matches the compliance path that somebody has chosen, right? If they're saying simulated building performance, they're just giving you a ResCheck. That's a red flag, right? That's a stop. That's a hold on a second here. This doesn't make sense. And again, it's a good reason to parse out which method they want to take, which prescriptive subcategory they want to take. Otherwise, then we start looking at the document. We say, okay, does the climate zone, floor area, building type all match? Then we work through the assemblies. We start going through that and the plans and saying, okay, do these match for the amount of wall area that they're calculating for this, ceiling area for this? Can I fit the amount of insulation into the ceiling area? That they're saying that they're going to get in our res check, right? Let's say that somebody decides to go with more ceiling insulation because they've got, the room for it and they're fine with that, but they want to really reduce the depth of their walls. It's a totally viable option, but again, we'd have to see that rightly configured on both of those. So we're going to check that insulation R value, the window U factor, solar heat gain coefficient. Thankfully, like I showed you, the software can pick up when inputs violate certain aspects of the code. The other thing to maintain there then is if you have any local amendments that change that, right? That's about the only other thing that really can throw that off. But otherwise, we're going to review all the other kind of places that might be potential weak spots and ultimately see that, hey, this shows the pass necessary. Now, for all my inspectors out there, it's a horse of different color, right? By the time you are getting to needing this document, chances are, other than maybe some slab insulation, the building's going to be sticked up, right? You've already been out on the job in a few different instances. And so the first thing you want to make sure is that report going to be there for you to consolidate the information that you need to review on site, make it easier to get through your process. After that, we're going to verify the installation type and R value match the report. So that way we can make sure that it's being built as designed effectively. Ceiling and roof insulation at eaves and over top plates. That's one of the big pinch points there, one of the big problems. As we use, I'm sure that folks that have been paying attention to this conversation for a long time know, the issues with getting things like high heel trusses in and things like that, or deeper framing members, TJIs for roofs in order to accommodate the depth of the insulation. We get those pinch points where roofs meet walls, where floors might abut rim joist, right? Things like that, where they're harder to insulate, they're harder to get the right depth. And so these become some of those key places that you want to make sure that the framing's accommodating appropriately and that we're not compressing insulation that we said, hey, we are going to get full height depth on that. That there weren't changes to the framing or the design that are going to cause those sorts of issues. Otherwise, we're verifying that the doors, windows match what was out there, the U factor, its solar heat gain coefficient, foundation insulation, location, and coverage. This is an important one, right? Because we all know backfilling is just a gentle process. People just lay chunks of earth in there very, very carefully. No, the reality is that if it's not made clear that hey, we want to be careful now that we attach the slab edge insulation. We want to make sure that's adequately protected during backfill. You can come out there and see it chewed up. I have certainly been in that position myself and said, whoa, 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 this is basically non-existent anymore. There are whole chunks missing out of this. And so, then what do, right? So it's not just about that end result of saying, hey, we have a building that finished the way that it should, but those incremental steps in the inspection process that help guarantee the good work by somebody else doesn't have a problem, right, down the road. So that's kind of the gist of impacts there. And so now I want to just take a quick digression and talk about something really quick here, which is, how do I use this thing? Like, how do we go about this? And the nice thing is that it's really easy to access. If you have not done this before, I strongly recommend that you do. So what I have here is my own personal ResCheck account and a particular design that I pulled up and just started playing around with here. We can actually go back a step. If I sign out, right? If you go to rescheck.web/login, or just Google ResCheck login. This will be, I promise, the first hit. You go ahead and sign in. It has a nice little policy saying, hey, I accept the terms. I get to work with you. And then we have a couple of projects in here, like I said, that I've been tooling around with just for some fun. And so we can pull up exactly what's in each of these projects. The other things that they have on the website that I want to give you a heads up about, they have a great glossary out there. So if you're trying to learn how to speak energy effectively, or you get somebody who you're encouraging to use the software and they're saying, whoa, 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 I don't know what half of this means. That's okay. Send them over here. Tell them, hey, give this a quick look. Look up the terms that you don't think you understand. This will help you figure out exactly what you're going through, especially on the residential side. Something like a glossary can make conversation so much more fluid and build so much more confidence in getting compliance on both sides of the counter. There's a nice map of states that can and cannot use ResCheck. Not too germane for Colorado here, but there are a number of places that run into that. So nice to have. There's also a full user's guide. Now, this is pretty sweet. It's not too technically demanding, I would say, and it walks you through the process of going through and using a product like this. Last but not least, I won't show it, but there is also a video on, hey, so you need to do a res check. So if you are talking to somebody at the front counter and explaining, hey, what you want to do by code, I need you to produce this document. They're saying, I don't know how. The nice thing is, there is this out here. It's an 8-minute video, does a phenomenal walkthrough on the basics of using the software, and can hopefully get somebody up to speed with what they feel comfortable with. So I wanted to take a little digression, do a quick little visit over to their website, and just let people know that this is a great place to go play around in when you have a few minutes of spare time. The nice thing here is that you can see if you start building a project, you can show the breakdown of each assembly. You can play around with their sizing, their location. You can talk about the windows. Like I say, all of these can be changed for individual items that they already have pre-programmed in here. So it really does cover and capture a vast majority of typical construction methodologies. And that's exactly what you want in a tool like this, in my opinion, is you're really just trying to catch the middle half of the bell curve, right? The majority of stuff that's going to come in at the front counter on a regular basis. And I think that a product like this really does do that, which is pretty cool. So let me jump back here. There we go. So I can't encourage you enough. Jump on in there, create an account, and just try it out. You won't waste time. And being able to build a sample res check like that can often pay dividends, whether it's for your staff or whether it's to walk somebody through it as a homeowner or as a builder who hasn't done this before. Being able to sit with them side by side instead of just saying, you'll figure it out. There's a lot of great resources out there to help support that. And so, last but not least, Erica did give you guys a quick spoiler. I was going to get the chance to talk about something that's pretty cool, pretty exciting. So, for those of you that might have been following the MLECC, that's the Model Low Energy and Carbon Code, they know that there was discussion about some of the changes made, some of the amendments made during the code development process by the code board out there, right? And what they ended up integrating ultimately did change the way that the code works at some very basic levels. And those basic levels mean that there are changes that effectively render ResCheck potentially unusable. And so, because of that, some of these items, I have a couple, well, I have one here for you, about the size limitations, right, for residential buildings, adding that three-tiered approach for crediting at 5,000 to 7,500 to over 7,500, requiring a net zero application for the build, right? There's a few different methodologies, that are included in just that one amendment that say, okay, ResCheck can't really accommodate that anymore. And so the Colorado Energy Office has built a component performance alternative calculator, and you can open that up. I suggest probably not trying to work with it on your phone. I did try it, and it is really cool. It's just in a spreadsheet, and I'll show some screenshots here, and that can be a little daunting. But you can go here and then either download a copy or send yourself the link, right? And hold on to it so that way you can get to it from your email address. Now, I don't know, Erica, if this was placed on Colorado or CEO's Energy Toolkit website as well.
It was, yes. And we're also going to be doing, I think we're scheduling a webinar specifically on kind of running through this resource because we've
Okay.
also created this for the ComCheck side. That hasn't been posted, but it will be posted this month. So stay tuned on that. But just as a heads up, if anyone is interested, that will be a webinar training where we can walk everyone through this calculator alternative.
Very cool. Is there a chance I could ask you to, if you have that link, to throw it in the chat for folks, just in case they have a problem with the QR code?
Yeah, let me see if I can find it real quick.
Thank you much. But otherwise, I'll wrap us up on our last couple of slides here. I think this is a really cool opportunity to see a homegrown solution on a obvious need in the market to fill this space. And so what you see here is sort of the first input sheet on this particular document, right? Where you can see, hey, you need to put your address in. We need to have some complying information put in about the project itself. And then as you get a little further into the document, you get some instruction pages that walk you through this. Now, what I noticed here in red, just to be very clear, right, this is for the homes less than 7,500 square foot because of the threshold that occurs where you go to net zero, right? That's a very different methodology, like I was mentioning earlier, than using sort of the typical prescriptive method. So that's why there's that leap. But otherwise, up to 7,500 square feet, which covers, the vast majority of residential homes, I'd say. Then you have your instructions there for inputting things like your climate zone, thermal conductance, and as you build out through the rest of the spreadsheet here, then you get to see sort of in live time what the ultimate U factor is for that. And there's links to the special documents that you probably need the most, like ASHRAE 90.1 Appendix A for your U factor tables. Some additional stuff from Applied Building Tech. They're a really great outfit, putting out different calculators out there for designing your wall assemblies. So some really good stuff contained in this, and just a unique new thing that Erica got to share with me just a couple of days ago. So I thought it was pretty cool. And with that, Erica, that is my spiel.
Awesome. Thanks so much, Andre, and I appreciate you highlighting the new calculator. All right, we're going to go ahead and open it up for questions. So if anyone has a question, feel free to write it in the chat, Q&A, or raise your hand and we'll go ahead and unmute you. But Andre will stay on the line for the next 3 minutes till the hour closes. So yeah, give us a holler. But if not, we hope to see you next month at it is not the first Wednesday of the month, it is the second Wednesday due to the ICC Educational Institute being on the first week. So, slight change up there, but stay tuned for more webinars to be posted, and we appreciate you all attending today.